Hello friends, in previous videos we have seen how to find out output impedance or impedance of any circuit. Today we are going to discuss about how to find out transconductance. Of circuits. So for finding this we need to first short output node to ground and then find ISC upon V in. ISC is basically short circuit current. So suppose this is given circuit and this is V in and this is output. We will short this to ground and this is ISC is short circuit current and transconductance is given by ISC upon V in. Okay. So here we are showing direction of IC current towards ground because this is lowest impedance node and current will flow towards lowest impedance node. Now first, so suppose this is output node, this is V in input node and this is ground. So this is output node. So we will short this to ground and this is ISC current, this is ID current. We need to find out ISC upon V in. So if we, so this is say output node, we apply KCL. So ISC plus ID equals to 0 and ISC equals to minus ID and minus GM VN. ID is GM VN. VGS is V in ISC. So ISC upon V in equals to minus GM. So this is, now this circuit, this is used as a input device in common source configuration. Now second one, so here we are going to use cascode devices. So this is some VB, so we ground this is V in and this is output node, we make it ground and here we will find out short circuit current. So this is ID, so ISC plus ID equals to 0, ISC equals to minus ID. So here ID is given by GM V in, this is ISC. So ISC upon V in equals to minus GM. So GM for this circuit is given by minus GM. So this is common source configuration but cascaded structure. Okay. So now let's go to third configuration, which is which we see here. So third one we will see. Now suppose it will be like this. Say this is some RS, this is V in and this is output node. We will short this, we find out ISC. Say this is VS node, here IS current is flowing. So this is ISC plus IS equals to 0, ISC equals to minus ISC equals to minus VS by RS. So this is say first equation A. Now we need to find out Vs in terms of V in. So how to find out this thing? So we draw small signal. If we see here, this will be 1 by Gm, so it will be something like this. 1 by GM, this is RO, and this is grounded. Here this is RS, this is RO, and here we are applying V in. So we have seen this kind of configuration so in previous lectures. So Vs upon V in is given by, so we add all resistances inversely proportional, all we take in parallel, Rs plus 1 divided by 1 by Gm. And so whichever resistance is connected with V in, that will come here like this. So Vs is given by, so Vs is given by, now we will multiply this V in. So this is equation B. We will put this here. We will get ISC upon V in equals to minus Gm divided by 1 by Rs plus 1 by Ro plus 1 divided by 1 by Gm into Rs. So this is Gm for this circuit. Now let us consider one case, which is we'll consider case. So suppose Ro is much greater than Rs, or Rs upon Ro much less than 1. We take it this side, so Rs by Ro less than 1. So Gm is given by minus Gm Rs by Ro plus 1 plus Gm Rs. Basically we are taking Rs inside this, and this is equals to Gm, because Rs divided by Ro much less than 1, so this we consider as a 0 as compared to 1, so we will put Gm Rs. Now consider another case further. We study this. If Gm Rs greater than 1, say, then Gm for this circuit is given by minus Gm Rs is, so this will be Gm equals to minus 1 by Rs. Basically this linearized our Gm depend upon only on Rs. So this kind of configuration is known as common source configuration, source degenerated common source configuration. Now next case we will consider this type of configuration. So this is a VO output, we make it ground, this is ISC current, and this is say some bias, so we make it ground, and we are applying V in here. Now in this case we need to find out what is our Gm. Now so this current is ID, so ISC plus ID equals to 0. ISC equals to minus ID equals to minus Gm VGS equals to minus Gm into VGS is minus 0 minus V in, so ISC equals to Gm V in. So Gm is given by ISC upon V in equals to Gm. Equals to Gm. So here Gm is coming as positive. So this kind of configuration is common gate configuration.